So, you're getting ready for a data science interview. You know that the exploratory data analysis question is coming, it's pretty much a guarantee. But what if you could flip that? What if you could turn it from something you're dreading into your single best moment to shine? Well, that's exactly what this explainer is for. We're going to build your ultimate playbook.
You see, here's the thing interviewers know. EDA questions are the best way to see how you think. They separate the candidates who just throw algorithms at a problem from the ones who are thoughtful, careful data scientists. The big question is, how do you prove you're one of the thoughtful ones? Let's dive into the playbook.
Here's how we're going to do it. First, we'll build the foundation with some core stats. Then, we'll get into the art of telling a story with visuals. After that, we'll tackle the test, those tricky gotcha questions. Then we connect it all to the payoff, which is modeling. And we'll wrap up with a quick cheat sheet for your final prep. Let's get into it.
Okay, first up, the foundation. This part is absolutely non-negotiable. You have to be able to speak the language of statistics with confidence. This is all about building that core vocabulary that shows you know what you're talking about.
So what is EDA, really? You can think of it as your first conversation with a new dataset. It's where you start to uncover hidden patterns, spot potential problems like outliers or missing data, and really start to build an intuition for what's going on. When an interviewer sees you take this step seriously, they see a careful, professional practitioner.
I can almost guarantee you're going to get this question. So, walk me through the summary statistics. What they're really asking isn't for a textbook definition. They're testing if you understand the implications of each of these numbers.
And check out this key interview point column. That's where the magic is. Look, anyone can define the mean, but a top-tier candidate says something like, well, I'd start with the mean to get a sense of the center, but I'd immediately check it against the median. If the mean is way higher, that's a red flag for me that we might have some high-value outliers pulling the average up, and that's the first thing I'd investigate. See the difference? You're not just defining, you're interpreting.
And if you really want to show a deeper level of understanding, you start talking about the shape of the data. When you mention skewness, you're showing that you're thinking about asymmetry, like income data, where a few billionaires create a long tail to the right. And when you talk about kurtosis, you're showing you're thinking about risk. A distribution with high kurtosis, what we call heavy tails, tells you that extreme events are more likely than you'd think. Think about stock market returns. That's a classic example. All right, so now we're moving from just numbers to actual visuals. This is the art of EDA. It's where you prove your analytical maturity, not just by making a bunch of charts, but by picking the perfect plot to answer a specific question and tell a real story.
And this is just so important. You can have datasets with the exact same summary stats that look completely different when you plot them. Visuals are what keep you from getting fooled by the numbers. It's how you show your evidence instead of just stating your conclusions.
Think of this chart as your go-to guide. Let's say the interviewer asks, how would you look at the price differences across several product categories? A fantastic answer would be, I'd start with side-by-side box plots. That way, I could immediately see how the median prices compare, how much price variability each category has by looking at the size of the box, and if any categories have a lot of high-priced outliers. Picking the right tool for the job like that, it's a huge sign of experience.
And speaking of box plots, let's just quickly break one down. It's such a simple chart, but it's packed with info. First, you've got the box itself. That's the middle 50% of your data. A tall box means things are really spread out. Second, that line inside is the median. Third, you've got the whiskers, which show you the expected range of the data. And fourth, any of those little dots floating outside the whiskers, well, those are your potential troublemakers. Those are the outliers you need to go investigate.
Okay, time for a slightly more advanced topic, correlation. It's not enough to just say two things are correlated. A tough interviewer might ask, okay, so which correlation metric would you choose here and why? Knowing the difference between Pearson and Spearman is what shows you really know your stuff. You use Pearson when you expect a nice, clean, straight-line relationship. But if you have outliers or a relationship that isn't a straight line but generally trends in one direction, you show your expertise by saying, for this, I'd probably go with Spearman because it's based on ranks, not the actual values, which makes it much more robust to those kinds of issues.
All right, Section 3 is all about the gotchas. These are the questions specifically designed to see how you handle messy, real-world data. But the goal here is to see them not as traps, but as the perfect opportunity to show off your structured, logical thinking. And here it is, the absolute classic. You've found outliers. What's your next move? Now, a weak answer is just, oh, I'd remove them. A strong answer, a great answer, always follows a clear process. Let's walk through that process.
First, you explain how you'd find them with confidence. You'd say something like, my first step is always visual. I'd use box plots and scatter plots to see if any points look totally detached from everything else. After that, I'd confirm what I'm seeing with a statistical test, probably the IQR method, since it's not easily fooled by the outliers themselves.
And this, right here, this slide is your perfect answer playbook. And the most important part, by far, is step 3, justify. The interview isn't about what you did, it's about why you did it. It's your thought process that's being evaluated. So always remember this framework: investigate, decide, and then justify. It shows real judgment, not just a technical checklist. Now we get to the payoff. This is what separates a junior data scientist from a senior one: the ability to connect every single finding from your exploration directly to a decision you make when you're building a model. This is how you show you're thinking about the entire project from start to finish.
This slide is basically a golden ticket. You're not just listing problems, you're proposing solutions. For example, in my EDA, I saw that the transaction amount feature was heavily right-skewed, so my plan is to apply a log transformation before feeding it into a linear model to help normalize it. Or, the correlation heat map showed strong multicollinearity between two features. To handle that, I'd probably use a regularized model like ridge regression. You're drawing a direct line from your insight to its impact on the project.
And here's a quick but absolutely vital tip. You have to be able to explain what you found to people who don't know or care about statistics. The ability to translate is a superpower. So you never say, "I found a bimodal distribution." You say, "My analysis shows that we actually have two completely different types of customers, and we should probably market to them differently." That's the language of business impact.
Okay, let's wrap this all up with a final review. Think of this as your last-minute cheat sheet, the key ideas you want fresh in your mind right before you walk into that interview room.
Let's do a quick rapid-fire round. Why visualize when you already have stats? Because stats can lie. Anscombe's quartet is the classic proof of that. When should you remove an outlier? Only when you are sure it's an error. Otherwise, it could be the most important data point you have. And how does EDA guide feature engineering? It's your treasure map. It tells you what to transform, what to combine, and where the most valuable new features are hiding.
So if you take one thing away from all of this, let it be this. Your interview is not a test to see if you can list a bunch of Python libraries. It's a test of your mind. They want to see a systematic, curious, and hypothesis-driven way of thinking. And EDA is the best stage you have to show them exactly that.
So now you have the playbook, from the fundamentals all the way to advanced strategy. The only question left is, how are you going to use it in your next interview to tell a powerful and compelling story with data? Good luck.